development lifecycle. The software development lifecycle is a framework or a process that most software companies follow. If you want to get software out on time and high quality and meet the needs of the customer, they typically follow something like this. This is an overall standardization of a lot of different ways and practices of doing this. When you build software, there's plenty of times where things don't go as planned. This graphic is just meant to kind of be a little bit comical. The customer thinks they explained this. The project leader thought it was this. System analyst, programmer, it keeps changing. It's kind of like the whispering game, you know, the whispering game where you tell somebody something and they pass it on, pass it on, pass it on. Eventually, what the customer really wanted or needed was just a tire hanging in the tree. But these things can get out of hand real quick when you get so many different people involved, just like the whisper game. You keep passing it down, and inevitably we put our own little spin on it, and it's not exactly what we want. Why is this important? Well, if the customer is the one that's going to pay you money, if you develop a product that they don't want, they're not going to pay you money for it. And you've already paid people, employees, money and time to develop something that the customers don't want. And so your goal is to make sure that what you deliver is what the customers want, so that they'll dump a whole bunch of money on you and you make billions like Apple or Microsoft or whoever. So the software development lifecycle, there will be a study guide out on the class website. It's not there yet. But the software development lifecycle basically starts here at the 12 o'clock position and moves clockwise around. So it moves from these 5 different phases: requirements analysis, design, implementation, testing, and then release, and then it's like shampooing, rinse and repeat. Okay? Requirements analysis starts something like this, where you interview, visit with, study the customer to identify what's the problem to be solved. What is it that what's their pain point? What are they looking for? At this phase, you focus on the what, not the how. Chances are the customer knows nothing about software. They know about their cell phone and their computers, and they can kind of explain it in terms or a vocabulary that they already understand. But if they're trying to do something brand new and different, you're kind of hampered when you're saying, okay, well, we want it to kind of be like that but different, and act like that but different, and do this kind of thing but different. So their vocabulary is going to be really struggling. But if they can focus on the what, and in this phase, if you focus on the what is it you're trying to accomplish? Leave the details to us. But at this point, you write what's called a functional specification that is reviewed by both the customer and the designers to make sure that everything's been captured in there, so the designers don't keep coming back to the customer saying, what did you mean by this? And then it moves on to the next phase, the design phase. The design phase focuses now on the how. How are we going to do this? Do we need a database? Do we need a server? What do we need? And you start taking the big problem that you learned about in the functional specification, you start breaking it down to smaller chunks. Oh, well, that part means we're going to need to store something off in a database. And so we need some communication pipeline to get the data into the database and get the data out of the database. You decide how each component works and how they're going to interface or connect with each other. And the end result here is a design specification. The design specification is now getting into technical terms, and this specification or document is reviewed by the designers and the implementers. Implementers are known as coders. They need to understand each other perfectly so the implementers aren't keep going back to the designer saying, well, what did you mean by this? Once that moves on, we move into the implementation phase. Implementation is where you really do the work finally, the coding work. It's usually the shortest phase. The end result is the program or the code that does the intended function. It's reviewed by the designers, the coders, and the testers. The testers are the ones that are going to try to break it. When I worked for Microsoft, name drop, when we looked at major Windows releases, usually a major release of Windows had a coding time of about 8 weeks. The time difference between major Windows releases was typically about 2 years. All the rest of the time was spent in requirements analysis and design, and then the next phases. But the actual coding part was the smallest part. So now we move into testing. Testing is where they're just trying to verify, saying, well, the customer in the functional specification asked it to do this, that, and the other thing. Okay, does it do this, that, and the other thing? Can it do it in the right quantity and scope? How many customers do we expect to be showing up to use it? If it's a website or something like that, at Family Search, we guess, saying over the weekend we think 300,000 people are going to hit this page. Well, if that's spread over what period of time? Well, let's test it. That means we've got 15 hits per second. Can the website and all the underlying services support 15 hits per second? You find that there are underlying components and pieces that can't do that. So you look for corner cases. Corner cases are, well, what if instead of 15 hits per second, we try to do 50 hits per second? Is it going to still stand up? How does it collapse? Is it catastrophic, or does it just kind of hiccup for a moment? Other corner cases, like when we're testing your calculator or things like that, put in big numbers, put in things that aren't numbers, and these different kinds of things. Your calculator was not written to handle all of those corner cases. But the end result is a test plan that's been executed and a program that works. It's reviewed by designers, coders, testers, and then we release it. We now put it in the hands of the customers and we say, give me money, please. Hopefully the customers, and you probably go back to the customers you originally worked with after you've delivered it to them, and you say, ta-da, now pay us money. And either they're absolutely in love with it, or immediately they said, oh, it'd be nice if. Well, great, you should have told me that months ago. But you get feedback for the next version. You might do some bug fixes or maintenance, minor things, and you start the cycle over. For the test, you're going to need to know this whole cycle, specifically these 5 pieces. There's a handy acronym called RADIATOR. If you remember Radiator Springs, Lightning McQueen, RA, requirements analysis, D, design, I, implementation, T, test, R, release. Any questions about software development lifecycle?